All right, we're going to take a crack at one of these integration problems where we use long division and possibly end up with a problem that requires partial fractions. So looking at this, it's a rational function, and we've got a degree that's higher in the numerator. So this is an opportunity to divide this denominator into the numerator in order to break it down and make it more easily integrated. So to do that, I'm just going to set up very carefully x to the third and then minus 0x squared minus 4x minus 10, and then I'm going to divide into that x squared minus x minus 6. Okay, well, I'm going to set up my trinomial expression down here that is going to eliminate that lead term. So what do I multiply x squared by to be exactly x to the third? It's just good old x. And then I multiply that times each of these. This is polynomial long division. It's a separate skill if you might need to look that up and brush up on it. But I get x to the third minus x squared there, x times x, and then minus 6x. And I draw a line. You can subtract. I like changing the sign automatically as I go across and then adding. These cancel as we want. We get then x squared. We add these and we get plus 2x, and we bring down the minus 10. What do I multiply x squared to give me x squared? Well, that's a plus 1. And when I do that to each of those, I get x squared minus x minus 6. And then when I change the signs and add, those cancel again, and I get 3x minus 4. That is the remainder. So this breaks down to be the integral. It's a definite integral from 0 to 1 of x plus 1 and then plus 3x minus 4 all over the denominator. And while I've got it here, I'm going to factor that denominator because that'll lead to the partial fraction bit of it. So what is that? X minus 3 times x plus 2. And then there's our dx. Okay. Well, I can do each of these separately very easily, but this is the integral that I'm going to concentrate on. So let's do the work of writing that in a partial fraction breakdown. So I know that if I have a over the x minus 3, and I'm adding that to b, I forgot the parentheses there, over x plus 2, that I will get these two things multiplied, and it'll be 3x minus 4. All right, so then I'm just going to multiply the a times both of those things down there, and I get ax plus 2a, and then I multiply the b times each of those down below there, and I get plus bx minus 3b. And as I multiply across like this, I would get that numerator, so that'll be 3x minus 4. Well, looking at just the x bits right there, that tells me that ax plus bx must give me the 3x, right? Because there's no way that these terms have x's in them to give me that. I can cancel the x's, and I get the a plus the b is equal to 3. And then looking at the constant part right here, and right here, I know that 2a minus 3b is going to give me negative 4. Okay, so I just have a system of equations, two variables, two unknowns. I can double the top and make it negative, so I'll write that down below here. Doubling that, making it negative, 2a will cancel with the positive 2a, doubling that, making it negative, doubling that and making it negative, drawing a line, and then linear combination, that's minus 10, that's minus 5 for the b's, and the a's cancel out. So clearly b is equal to 2, negative 2, negative 2. All right. Oh no, what am I talking about? That is positive 2. Well, if I know that b is positive 2 and I plug it in there, then a is going to be 1. So a equals 1. So I go back up here. Well, let me take and recopy this problem from above. I'm going to get the integral then from 0 to 1 of x plus the integral from 0 to 1 of 1 plus the integral from 0 to 1 of which is 1 over x minus 3, and these are all dx. I'm getting sloppy in my notation here, and then plus the integral from 0 to 1 of 2 over x plus 2, okay, dx. So then I can start integrating each of those carefully. I could have, of course, just kept them all simple terms, but I'm trying to emphasize the fact that we're splitting it apart and breaking it down. So this just becomes then 1/2 x squared from 0 to 1 plus x from 0 to 1 plus, okay, well, what is this? This is just going to be the ln of the absolute value of x minus 3 from 0 to 1 plus, in this case, it's going to be, I can bring the 2 out front, and then I've got 2 times the ln of x plus 2 from 0 to 1. And when I evaluate this, I will get 1/2 minus 0 plus 1 minus 0 plus the ln of 2 minus the ln of 3 plus 2 times the ln of 3 minus the ln of 2. And I can combine these guys, so that's 1/2 plus, well, what is this? This is going to be the ln of 2/3 plus, here's the ln of 3/2 times 2 as an exponent, so that's going to be the ln of 3 over 2 squared. And then since we're adding these, the final answer would be 1/2 plus the ln of, if I do the squaring, that's going to be 9 times 2, that's 18 over 4 times 3 is 12. I guess I could have canceled a couple of 3's in there. That would have made it easier. But what is that finally? That's going to be equal to the ln, or sorry, 1/2 plus ln of 3 over 2. So there we go.